This example asks us to find the length of the unknown side, and we have a right triangle with one of the legs being 4 centimeters and the hypotenuse being 7 centimeters, but we are missing the length of the other leg. I'm going to call that x. Okay, and anytime you see a right triangle, especially when it's asking about the length of a side, one theorem should jump right out: the Pythagorean theorem. The Pythagorean tells us that a squared plus b squared equals c squared, and I highly recommend memorizing that if you don't have it already memorized. A and b can be either of the legs, those are interchangeable, but c must be the hypotenuse, right? C has to be the hypotenuse. Okay, so we'll call this c here, and let's use this x as a and the 4 as b. Okay, bringing this into the Pythagorean theorem then gives a squared, so x squared, plus b squared plus 4 squared equals c squared, 7 squared. And then we just need to solve for x. So we have x squared plus 16 equals 49. Subtract the 16 from both sides. X squared equals 49 minus 16 is 33. And then square root both sides to get at the x. Now, we don't need to put a plus or minus on here because we know x is a distance, and those are always going to be positive at this point. So we'll just take the positive square root. That gives us x equals square root of 33 centimeters. Now, sometimes problems like this are going to want you to leave it in a pure mathematical form, like rad 33, but if you were measuring out this distance on, say, a piece of lumber or metal, you would want something more exact than that. It's hard to find square root of 33 on a ruler. When I put that into a calculator, I get about 5.744. So let's just round that to one decimal place, 5.7 centimeters. And usually the problem will tell you how many decimal places to round it to. So we'll just do 1.